Good morning, Year 4. It is Wednesday the 3rd of March and this is another lesson about moving shapes. Remember yesterday we talked about this word translation, and this is the mathematical word for moving a shape on a grid. You're picking it up and you're moving it somewhere else, and we talked yesterday about making sure we weren't going to turn the shape, we weren't going to flip the shape, we really were just moving it left, right, up and down, and that's really quite important to remember, children. So think about this as a key word, key vocabulary for our lesson today. Okay, so let's just have a look at yesterday's challenge. It says Ron translates the point 2, 3, but realises that it has returned to the same position. What translation did he do, and is there more than one answer? Well, there is more than one answer for sure. So what this is saying is that he starts here and he translates it, but then he actually ends up in the same place. So what has he done? How has he moved this to then end up back where he started? All right, took a bit of thinking. So you could do something like one to the right and then one to the left and end up back where you were, okay? Or you could do something like this as well. You could end up going sort of round in a circle, really. One to the right, one up, one to the left, and one down. But there are other answers, because you could go, instead of right first, you could go left first. You could go down first and then round in a little circle like that. Or you could even translate it more than one space. You could say, 3 to the right and then go round in a big circle like that. There are lots of different answers to that question. But just so you know, you can translate a shape such that it moves but then ends up back where it started. A bit of a trick question, really, that one. I hope you had fun with it. Okay, so today says, how can we move rectangle A, B, C, D so that one of its vertices ends up on 7, 8. So there's there's the point 7, 8, 7. There's the X, 8. Yeah, 7, 8. So we want one of its vertices, one of these corners, to end up there. All right, that's like our problem for today. Now, if you want to stop before I go into Let's Learn, you could pause and you could have a think about how am I going to get one of those corners, one of those vertices. And a vertice is a mathematical term for a corner. One of those corners there, that point there. So you can pause and have a think if you want, or you can listen to the rest of the video. Okay, so 2 children have a little go. And you can see that 7, 8 is here, this bit here. Yeah, okay. And I always like, when I'm doing these translations, I always like to name at least one corner so that I can see where the shape is going. So if you struggle a little bit today, it might be an idea for you to name all the corners if you want, or at least one of them. So the little boy is saying, move it up 2 units and then 5 units to the right. So move it up 2 units. So there's B. I'm trying to get to 7, 8. 2 units, 1, 2, and 5 to the right. 1, 2, 3, 4, 5. But the little girl says, translate it 5 units to the right and then 2 up. So let's try hers. 5 to the right. 1, 2, 3, 4, 5, and then 2 up. 1, 2. Who is correct? Well, that's a bit of a trick question, because you can see, children, I've just shown you that actually both those translations are indeed correct. And sometimes, well, most of the time, actually, you can have more than one answer, depending on whether or not you want to go up first or right or left first. So there will be more than one answer for quite a lot of the work that you do today. Okay, so this time it says we've got this point here, This is B, so you can see, and you can see we've got a part of the rectangle 7H there, so that must be point A, must be on 7-8, okay? But again, I just like to sort of know that that bit there is B and that bit there is A, so I'm sort of labelled some of the rectangle. She says translate it 4 units upwards and then 5 units right. So let's go. 4 units up, 1, 2, 3, 4, and then 5 right. What? Oh, come on. 1, 2, 3, 4, 5. Yeah, it ends up there. That's right. Remember, children, when you are counting across, you're not counting the squares. I'm not putting my arrow in there and counting each square. I'm counting each point where the 2 lines cross. So you can see there, I'm counting on actually that point there. All right, and you could translate that in a different way as well, but that's the way that she has chosen. Okay, so this time we've got 0.78, which is what our first question was. 7, there's 7 and 8 there, that point there. I've shown you that that's B, so if that's B, this part of this rectangle must be D. D is translated to there, all of it's translated to there. So have a little think, pause the video. How is this one translated? Has it gone right, left? Has it gone up or down? Have a little pause and then we'll discuss the answer. Okay, so this time we've translated 2 units to the right, 1, 2, and then 4 units upwards, 1, 2, 3, 4. Okay. It could be the other way around as well, couldn't it? You could have decided to go 4 up, 1, 2, 3, 4, and then 2 to the right, 1, 2, yeah? So it doesn't really matter which way around you do it. Okay, so this has been translated. Again, we've got a point on 7-8, which is what our question asked at the beginning of the lesson, 7, 8 there. So that's, because if that's B, this must be C has moved to 7-8. So the rest of the rectangle is in that position. Okay, what have we moved this time? How have we, this is a bit harder, I think. How have we moved this time? Just because the 2 rectangles are next to each other, I think when there isn't a space, it can be a little bit confusing, and that's why if you wanted to, you could write all 4 vertices in and then you would see. How is this one being translated? Let's have a look. Well, it's gone 2 units upwards and 2 units to the right. Let's just double check that. So it's gone 2 units upwards, 1, 2, 2 to the right, 1, 2. Yeah. You can check that for all the points if you wanted to as well, all the vertices. So there's D, 2 to the right, 2 upwards rather, 1, 2, 2 to the right, 1, 2. But it works the other way as well. So you could go 2 to the right, 1, 2, and then 2 upwards, 1, 2, and you get it to there. Okay. Right, so your task is a parallelogram, is drawn on a square grid. Describe the translation JKLM. So this time our shape is called JKLM. And it says, describe what's happened if point J, there's point J, is moved to 4, 7. So J is moved to 4, there's 4, 7, and ends up there. Now what you might want to do is put that point there and redraw the parallelogram for these questions so that you can actually see, you know, like on this one here, the whole shape was redrawn, even though she started with this question about 1 point being at 7, 8. The whole rectangle each time was drawn. So you might find when you're doing your questions today, children, it might be easier for you to draw the whole parallelogram, okay? So you'd look at that point there, 4, 7, and that's going to be J, okay? and it's moved. So you can move each of those the same way. So J has been moved from there to there. Yeah. So it's come down one and right one. Yeah. So then each of them will move the same for you to draw the parallelogram accurately. That's what I'm trying to say. All right. There is a little challenge. It says triangle to X is 4 right and 4 down. X to triangle is 4 left and 4 up. Can you plot other pairs of points where to move between them you travel the same left or right as you travel up and down? Right, a bit to think about there. What do you notice about the coordinates of these points? So each of the movements have got to be the same. So 4 right, 4 down, and then the other way round will be 4 left and 4 up. Okay, a bit to think about there. Okay, you can upload your work on Teams as usual or email me, and don't forget to go on TT for about 15 minutes, and I will see you next time. Thank you, boys and girls.